What's up guys, this is Massey. Welcome to another video. In this video I want to show you some examples regarding integration by substitution. First example is sine theta times cosine theta subtract 3 to the power of 6 d theta. How do we deal with this equation? So we have cosine theta minus 3 to the power of 6 and we have sine theta in here. If we want to use integration by substitution, I'm going to have u equals to cosine theta subtract 3 and we have du over du, which is the derivative of this function, is going to be negative sine theta, which is the derivative of cosine. The derivative of negative 3 is 0. And we have d theta as well. As you see in the question, we have sine theta and d theta. So negative du is going to be equal to sine theta d theta. So I can rearrange the new equation as u to the power of 6 times negative du, which is negative u to the power of 6 du. When you integrate it, it's going to be negative u to the power of 7 over 7 plus c. Because the integral of u to the power of n is going to be u to the power of n plus 1 divided by n plus 1. So the answer is this, and I need to convert it back to cosine theta minus 3 to the power of 7 plus c. So that is the final answer. Next example. Integral of cosine 2x times sine 2x dx. In this case, since this part is under square root, it's better to consider cosine 2x as u. So du is going to be, the derivative of cosine 2x is going to be negative 2 sine 2x dx. We already have sine 2x dx. It means that sine 2x dx equals to negative du over 2. So that's going to be square root of u times negative du over 2. So we have negative 1/2 integral of u du, which is going to be, since square root of u is u to the power of 1/2, it's going to be u to the power of 1/2 plus 1 divided by 1/2 plus 1 plus c. So that's going to be negative 1 over 2 u to the power of 3 over 2 divided by 3 over 2 plus c, or when you simplify it, 3 over 2, when you move it to the numerator, is going to be 2 over 3. 1 over 2 times 2 over 3 is going to be 1 over 3. So it's negative 1 over 3. U to the power of 3 over 2. U is cosine 2x to the power of 3 over 2 plus a constant number. Next question is going to be sine to the power of 5x times cosine x dx. This is a little bit simpler. I'm going to have u equals to sine x. So du is going to be cosine x dx. That's going to be u to the power of 5 times du. So when you integrate it, it's going to be u to the power of 5 plus 1 divided by 5 plus 1 plus c. So it's going to be 1 over 6 u to the power of 6 plus c. So that's going to be 1 over 6 sine to the power of 6x plus c. That's the final answer. Next one is cosine to the power of 5x sine x dx. Very similar to the previous example. Here it was sine to the power of 5x cosine x. Here we have cosine to the power of 5x sine x. So u is cosine x, du is negative sine x dx. That's going to be We have sine x dx, so it's negative du, so it's going to be u to the power 5 times negative du. It's going to be negative u to the power 5 du. That's going to be negative u to the power 5 plus 1 over 5 plus 1 plus c. So we have negative 1 over 6 u to the power of 6 plus c. Negative 1 over 6 cosine to the power of 6x plus c. Now let's change it a little bit, and I'm gonna have something like sine to the power of 3 5 theta times cosine 5 theta d theta. How do we deal with this kind of examples? Again, I'm gonna have u equals to sine 5 theta. So du is going to be 5 cosine 5 theta d theta. So cosine 5 theta d theta is going to be du over 5. So cosine 5 theta d theta is going to be du over 5. So we have u to the power of 3. Du over 5 is going to be 1 over 5 u cubed du. Then we have 1 over 5 u to the power of 3 plus 1 over 3 plus 1 plus c. So we have 1 over 5 u to the power 4 divided by 4 plus c. So we have 1 over 20 u to the power 4, which is sine to the power of 4 5 theta plus c. So that's the final answer. Another example for substitution, we can have ln x to the power of 4 divided by x dx. So I'm going to say u, if we consider it as ln x, du is going to be 1 over x dx. Then it's going to be integration of u to the power of 4 times du. That's going to be u to the power of 4 plus 1 over 4 plus 1 plus c, which is going to be equal to u to the power of 5 over 5 plus c. So 1 over 5 ln x to the power of 5 plus c. Next example. E to the power of x plus 1 over e to the power of x plus x dx. How do we deal with this kind of question? I'm going to say u equals to e to the power of x plus x. So du is going to be the derivative of this, which is going to be e to the power of x, and derivative of x is 1 dx. So that's going to be du over u, which is going to be ln u plus c. And u is e to the power of x plus x. So e to the power of x plus a constant number. Next example. E to the power of x over 3 subtract e to the power of x dx. So in this example, I can say u equals to 3 minus e to the power of x. Du is going to be negative e to the power of x dx. So e to the power of x dx is going to be negative du. So that's going to be negative du over u. So negative du over u is going to be negative ln u plus c. So it's negative ln 3 minus e to the power of x plus c. That's the final answer. Next example. 1 plus e to the power of x over square root of x plus e to the power of x dx. You're going to say u equals to x plus ex, and du is going to be 1 plus ex dx. So that's going to be du over square root of u, which is going to be u to the power of negative 1/2 du. That's going to be u negative 1/2 plus 1, negative 1/2 plus 1 plus c. So that's going to be u to the power 1 over 2 plus c, which is going to be 2 square root of u plus c, 2 x plus e to the power of x plus c. Next example is x over x squared minus 3 dx. So this is a simple question. Again, integration by substitution. Consider u as x squared minus 3. So du is going to be 2x dx. Therefore x dx is du over 2. And that's going to be du over 2 over u. So that's going to be 1 over 2 du over u. And that's 1 over 2 ln u plus c. 1 over 2 ln x squared minus 3 plus c. Next example. Cosine root x over root x dx. U is root x, du is 1 over 2 root x dx, which is going to be 2 du equals to dx over root x. That's going to be cosine u times 2 du. That's going to be 2 cosine u du. 2 sine u plus c, which is 2 sine square root of x plus c. C again is the constant number. It can be any number, any constant number. Next example is integration of e to the power of x minus e to the power of negative x over e to the power of x plus e to the power of negative x dx. So we have u equals to e to the power of x plus e to the power of negative x, and du is going to be e to the power of x minus e to the power of negative x dx. So we have du over u, that's going to be ln u plus c, and that's going to be ln e to the power of x plus e to the power of negative x plus c. Next example. Y over 1 plus 3y squared dy. This example, I'm going to consider u as 1 plus 3y squared. Du is going to be 6y dy. It means that y dy is du over 6. So we have du over 6 over u. And that's going to be 1 over 6 du over u. And that's going to be 1 over 6 ln u plus c. That's going to be 1 over 6 ln 1 plus 3y squared plus c. Next example. X times cosine x squared over square root of sine x squared dx. That's cosine. So in this example, I'm going to consider u as sine x squared. Therefore, du is going to be 2x times cosine x squared dx. So du over 2 is going to be x times cosine squared x squared times dx. So we're going to have du over 2 over square root of u. So we can take 1 over 2 out, and we have u, since it's in the denominator, is going to be 1 over 2, u to the power 1 over 2, and when you bring it in numerator, it's going to be negative 1 over 2 du. When you integrate it, it's going to be u to the power of negative 1 over 2 plus 1 over negative 1 over 2 plus 1 plus c. That's going to be u to the power 1 over 2 plus c, and that's going to be square root of u plus c, and that's going to be sine x squared plus c.